Welcome to technical session number 22, I believe it is. It's typed in here. It's not like that's never happened before, but we can move right on through that. So client-side virtualization, where we will be talking about setting up virtual machines on other computers. What does that mean? We're going to define virtualization, describe its purpose. Why would we use such a thing? List some of the requirements that you're going to need to set up and use virtualization, and describe how to use client-side virtualization in and of itself, and identify some potential pitfalls to using client-side virtualization, including some security concerns, some which we briefly mentioned in the previous session, like VM escape, where a virtual machine on a device can become infected and find a way to escape that virtual box and infect the host systems and stuff like that. So that always can be a concern as well. All right. So kind of in your own words, think about it. How would you explain virtualization to a client? I know we haven't specifically defined it yet, but in your mind, how would you define it?
Are we writing it? Or?
Yeah.
Oh, okay.
Put in some answers. Okay, running an operating system, a separate box. Virtual computer, not a physical computer. Is that like those VR headsets I keep hearing about on the news? Copy. Okay. A couple more in there. Almost like two computers in one. More like a simulation. I like that. Creating a virtual rather than an actual version of something. Okay. All right. Good takes on that. So here's kind of an overview. Yeah, we're creating operating systems on a separate computer that we can utilize. Sometimes we're setting up these operating systems like virtual desktops where other people might be using thin clients, logging into our system and running off of those virtual machines on it. And there are two types of virtual machines that we will get into, or virtualization. Hypervisors is what they call them. That we will talk about going forward here a little bit. So, let's see here. What exactly is the purpose of a virtualization? JR, can you read for us, please?
Virtualization purpose. While workstations can run multiple operating systems, they cannot run them at the same time. With virtualization, the same workstation can run many different OSs simultaneously on different virtual machines. This saves hardware costs when needing to have access to different operating systems for many reasons, including testing software on different platforms, working in a support environment, and developing new code.
Beautiful. So it kind of lowers your barrier to entry or your cost to entry. Like when you're setting up an IT department, you can run virtual machines of different versions you may have running in your company and be able to test software updates, things like that, and see if they're going to affect your systems negatively before you implement them into the work environment. Also, if you're developing new code, you want to see if it works just as good on Service Pack 2 of Windows 7 as it does on Service Pack 5 of Windows 10, right? So make sure these things still kind of can work together. Yes, Kevin.
I can't help but feel that boot camp is very similar to virtualization. Is like
Not exactly. That is a multi-boot process, so that is a little bit different definitionally.
all right.
So
I was just curious about that. That's
no. I mean,
what I was
you
looking
know,
for.
I see where your head's at, but it's kind of the same but different.
Okay.
is
Yeah.
what I'm
No.
getting at.
I was just looking for whatever answer you get. Like I wasn't.
Yeah. So, but it's interesting. So instead of creating a virtual machine or a virtualized machine on an operating system, you're booting directly into that operating system. So that is a multi-boot process where you're going straight into it versus having the software run on top or a hypervisor creating it for you.
Oh, okay. I understand that. All right.
So, but we'll get into a lot of this stuff here in just a few minutes. All right. So hypervisor. Shamika, can you read for us, please?
The hypervisor, the key enabler for virtualization, is a piece of software called the hypervisor, also known as Virtual Machine Manager, VMM. The hypervisor software allows multiple operating systems to share the same host. It also manages the physical resource allocation of the VMS. There are two types of hyperversions.
Hypervisors, yeah.
Type 1 and type 2.
Thank you. So we're focusing primarily on two different types of hypervisors, type 1 and type 2. And basically the hypervisor kind of manages everything. It allows you to run multiple operating systems on top of, what they call the virtual machine manager, so that the same host can share these different versions, or they could be multiple versions of the same kind, and just people are using each instance of that. They manage the resources, because as we remember, when we were talking about Windows, like Windows 10 64-bit, well, we need 1 gigahertz processor, we need 2 gigs of RAM and 20 gigs of storage space. So we need allocation of these resources within the hypervisor. The hypervisor is going to divvy out those resources as they're needed so that the system can actually function. Type 1, also known as a bare metal, meaning the hypervisor itself is installed directly on top of the hardware or the software is run. There is no host operating system on the hypervisor in a type 1. This is essentially set up to share and manage hardware and resources between different operating systems. So like if you're setting up a virtual desktop environment where all your employees are going to be logging into the same system, utilizing these individual instances or virtual desktops, you would set up a type 1 hypervisor. It's significantly faster. Downfall is it's a bit more expensive. So Hyper-V, Citrix, Zen Server, you might have seen some of these if you worked in an office where they utilize virtual desktops. So Citrix is one that I had to use on a regular basis in my previous company. But these are some primary examples of this. Type 1, bare metal. There is no host operating system between the hypervisor and the actual hardware. So the hypervisor has all the containers built directly on top of it. Type 2 is one you may be a little more familiar with in your everyday life if you've dealt with things like VirtualBox, VMware, Workstation, things like that. That is known as a client-side virtualization. The software is installed on top of your already pre-existing operating system like Mac OS or Windows 10 or what have you. And you would go out and you would get third-party software like VirtualBox or VMware, install that on top of yours, and then you would create the instances on top of that virtual or type 2 hypervisor. So you would have the hardware, you would have your host operating system, and then you would have the hosts created or the clients created on top of that. Whereas bare metal is just the hardware, and then the containers are built on top of that. Here's kind of what it looks like a little more physically. So you have the hardware, the hypervisors built on that, and then they have what are called containers. So each virtual instance you're creating where you would have like a version of Windows 7 with whatever applications in there, that would be called a container. It is an individual grouping or instance on top of your hypervisor. So this one here would show two different containers. So you could have like Windows 7 right here and Windows 10 right here. So two separate instances, you'd have two containers on top of your hypervisor, but there's no host operating system. It's just hardware, hypervisor, containers. Type 2, you have your hardware, your host OS, like your Windows 10 or what have you, operating on top of that hardware, and then you would install a third-party hypervisor software like VMware or VirtualBox, and then the containers would be built on top of this. Downfall or positives of this, type 2 is less expensive. You're not utilizing specialized, hardware. You basically can take a computer off the shelf and create this if you wish. Much of the software, the third-party software you would use is free, but your host OS is going to be utilizing some of those resources, so that actually diminishes the available resources you have to create containers, and it's going to run slower. So it's not going to be as efficient as a type 1 hypervisor. But for the most part, type 2 is the most common.
So type 1 is a computer specifically made for doing that.
Yes.
And type 2 is just any old computer that was then configured to do it.
Yeah, it's any old computer where you can do this. Like you can take your computer that you're on right now and create a type 2 hypervisor.
Okay, but type 1 is just like it's built for that purpose and for that purpose alone.
Correct.
Okay.
Questions? This is a good one to take a picture of because it kind of gives you a really good visual as to the difference between type 1 and type 2. That sad moment with the caffeine right now.
Do we have the student link of this one or this?
I believe, has it been dropped yet, DW? Yeah, it's in
That
Slack.
dropped one, but it's cloud. It's cloud computing.
Yeah, there's another one in Slack. I think he put another one in there.
Okay, thank you.
So, client-side virtualization allows you to run multiple operating systems on one physical workstation. And you have to understand going in that's going to require more resources than running a single operating system. Remember, client-side, we're talking about type 2 hypervisors right now. So for performance reasons, you kind of want it to be well equipped for what you're trying to do. Type 2 is going to divide those resources up amongst the host operating system and each virtual machine that you're creating. So you need to make sure you have the resources on hand. If you are creating multiple ones of these, it is absolutely critical that you turn them off when you're not using them. Otherwise, they will continue to chew up those resources and slow your system down. Excuse me. Primary reasons or resources that you need to pay attention to with regards to hypervisors. CPU, you want multiple cores. RAM, probably about as much as you can get. And hard drive space, because remember, each instance of these operating systems may be 20 gigs of space. That's a lot of space. You can eat that up pretty quick. And that's just for the operating system. That's not allocating more space for applications and other stuff that you may be doing on each instance. That's just the operating system, 20 gigs. So that's bare minimum. So you want multi-core, like we were just talking about, since the hypervisor can treat each core as a separate virtual processor. And remember, where you have hyperthreading, each core can be treated as two, right? Because it can process two instances at each time. So multi-threading becomes important, and multi-core. So some hypervisors require the CPU to be specifically designed for this, or at least have it enabled. So you would actually, in many cases, go into your BIOS and enable or allow hypervisor or virtualization on your system before you can even install it or begin to run it. I ran into this on my Mac. When I was trying to install and run VirtualBox, had to go in through the BIOS and enable it. All right. Next, memory or RAM. Always a concern. You need to make sure you have enough for each instance you're going to be utilizing. So if the host operating system requires 4 gigs of RAM, the guest OS requires 2, then you'll need a minimum of 6. You got to add it all together. Minimum of 6. So you need to allocate for this. All right.
Kelly.
Yes.
With the RAM and everything, but if it was a hypervisor 1, it wouldn't really need to it wouldn't need to worry about a host OS, right? Like it would just need to worry
Correct. So
about
the host OS would not take up some of those resources.
yeah, okay.
Absolutely correct. All right, we'll get it dropped in there, Greg. Here. There you go. It's dropped. All right. So inside your BIOS, looks something similar to this. You're going to make sure you're going into virtualization technology. Right here, it looks something like that. And you would have to enable it. Now, I know what y'all are thinking.
Is there a lab for that? I'm
Yes,
glad you
there
asked.
is. I am so glad you asked. Yes, there is a lab that goes through all of these steps. So yes, you all can get some practice in test out going through all of these things. So if you're creating a virtual network in and of itself, a virtual network, each VM instance can have its own IP address. So it can communicate on the network itself. So the VM, if you want it to be networked, it can create a virtual NIC or network interface card for each instance and manage the resources of that NIC. And it doesn't have to be connected to your physical NIC. You can have them connected to each other, but not to the physical NIC. So they can communicate with each other, but not go out into the world. So if you're doing testing and stuff like that, that would be one way you could do this, to where your virtual machines can communicate with each other, but cannot go outside. Now, if you want to connect it to your physical NIC, you would have to set up something like this. So each instance, so say we had 3 instances. We had 3 virtual machines. Each virtual machine would have its own virtual network interface card attached. And they would need to be connected to a virtual switch. And then that switch would be connected to your physical NIC to get out to the outside world. I would take a picture of this because I had at least 2 questions that came up basically involving just this graphic. So you can set it up in 2 ways if you wish. You can still have this virtual switch where they can communicate with each other, or you can set up bridge networking, which allows those internal ones to access real world resources. So you have internal networking versus bridged networking. Questions? And here in the virtual machines, you can create your own IP addresses. You can put in whatever IP address you want. You can put in whatever MAC addresses you want for the NICs. So remember we were talking about where you have MAC filtering, where only devices with specific MAC addresses can access your networks. So here in this, you can create a network interface card, put your own MAC address in it so you can set it up to mimic the MAC address of another system and gain access to that system. We'll see a little bit later how easy it is to create a virtual machine.
It's like it's a virtual machine, like an example of like what will you be using on like test out lab, like the way we do the labs, like those type of platform, or
Coursera, you know, like you know, when it says launching VM, that's virtual machine.
Oh, okay.
You know, test out labs, yeah, I guess you could call it that too. But a very clear example would be the Coursera ones that you do, where you actually have to go out to the internet and download the stuff you're looking for.
Okay.
Is that what Citrix is too? Because I've used that.
Citrix is a type 1 hypervisor. Yeah, we were talking about that a little bit earlier. That's the one I'm most familiar with. When I worked in transportation, that's what we used. So questions on this one? All right. Security requirements for virtual machines. Just like regular computers, the security concerns that will affect your virtual machines are the same as they would be for your computer. They are vulnerable to they are vulnerable to hackers. They're vulnerable to malware, just like regular machines. And if they have access to the internet, they must be protected. And they must be isolated from the rest of your machine and have permissions secured for files that the VM themselves holds. So you would need to actually have an anti-malware device or system program running on each individual virtual machine. The one that is protecting your computer isn't going to protect the VMs. So every instance you have, if it's going out on the internet, needs to have its own anti-malware protection. So you have to make sure that the antivirus programs that are on each of your virtual machines are kept up to date, as well as the guest protocols as well. All right. So different from a virtual machine, you have an emulator, which runs one type of program on a platform that is different than it was originally intended. Like if you wanted to run Android games on a PC, if you want to play old Atari games, and you want to do that on a PC, if you've seen those little box like Nintendos that you can buy at Walmart or whatever, or the Super Nintendos or the Genesis or whatever, you know, those are essentially Raspberry Raspberry Pis that have been made to be emulators for these types of video games. Now, in the past, they may have been used interchangeably, but hypervisor and emulator are two different things. Where the hypervisor emulates hardware and presents this virtual hardware to each virtual machine. Hypervisor also supports multiple operating systems, where an emulator is typically only able to operate with a single operating system or one specific operating system. And the only requirement for the emulator is that it be compatible with your host operating system. That's all. Yes, Tomas.
So if, say there's an emulator software that can emulate more than just one console, would it be considered a hypervisor if it
No.
can do more than just one?
I think I know what you're talking about, like where you plug into it and it essentially has all the consoles in one piece. That
Yeah.
would be the emulation. So it's emulating to be able to do all that. Those aren't each that you're not looking at just a Sega, just a Nintendo, just an Atari. It kind of just has everything in one and you're just able to play it.
Yeah.
So it's still an emulator operating one particular type of software compatible with this operating system.
Okay.
I like the nuance in that question though. That's really good. All right. VDI, or Virtual Desktop Infrastructure. This is like the process of running a user desktop inside a virtual machine that lives on a server, usually like in a data center or something like that. This is a great one because this allows you to kind of personalize it and it still be the same when you come back. If you've ever worked at a company where, I mean, I've had this where it didn't matter what computer I logged into, it didn't matter where I was, as long as I had my sign-in and password, it would bring up my desktop right there. All my saved files, everything, wherever I was. My access was my sign-in and password to get into the server, and then the server would, you know, give me my VDI or virtual desktop infrastructure, give me access to this. So it allowed for a lot of freedom. I didn't have to carry stuff with me all the time. If something happened where I didn't have access to my desk, like if you're using hot seating in your office, or if you're running multiple shifts in the same office, your desk may get used by multiple people. So when you come in, it doesn't really matter which desk you sit at. You pick a desk, you sign in, and then you get brought into your desktop. And this is considered a server-based virtualization. But I would remember that VDI, virtual desktop infrastructure, allows personalization of the desktop and mobility. All right, so basic steps using client-side virtualization. First, we need to determine the client's need for it. Do they really need it? You know, is this something that would help them, would improve their business experience? If that is determined to be yes, then we would evaluate the resources that they have at their disposal to see if we can set it up on their systems. CPU capacity, how much RAM, free hard space, network connections, all that kind of fun stuff. Type 1 or type 2 hypervisor, are we buying new equipment or are we utilizing what they got? Security requirements, are they using this just kind of like as a testing facility to see how things work? Or are they, you know, going to actually be running these things over the net? In which case we need to make sure we have up-to-date security on each of these instances.
You have an audio issue.
Who is? Can you hear me?
It sounds like the mic in your headphone went out. It sounds like you're coming through your desktop.
I can hear him great.
Anybody else experiencing my audio changing?
No.
Like,
Oh, it's just me then? Sorry about that.
Hyper-V is considered a type 1 yes, Oscar, for the purposes of A+. All right. So using a hypervisor, here is, we're going to go through these next 8 slides pretty quick because this is just installing a hypervisor on your system. You have the student pace ones, you can walk through this. I do encourage you guys to go out and try to install a hypervisor on your computer and just kind of see how it works. You can get a version of Linux for free, load it on there, practice with Linux. You can do this with Windows, you know, and use them for a little while, and then you can delete the instances if you want. Mac OS, it gives you experience with these other operating systems and how they work. So I highly encourage you to go out, download the software, and give it a shot. It's free. And good practice. So you download VirtualBox, come into your VirtualBox once it's done, create a new machine. Next, name that machine. Please try to name machine something that will remind you what it is. Because if you're creating multiple machines with different versions, don't call it like VM1. That's not really going to tell you what it is. Maybe call it like, you know, Windows 7 Service Pack 2. You know, something along those lines that'll tell you what it is. See here. After that, select the guest operating system you're going to be using. Are you going to be using Windows, Mac, Linux, what? If you're using Linux, what distro are you using? So this is where you would make all these selections and determine what kind of hypervisor you're using. After that, you're going to go in and allocate the resources. How much access to resources are you going to allow it to have? How much hard drive space? How much RAM? And understand, especially with the RAM, whenever this thing's turned on, that RAM's not going to be accessible to your main computer. Hard drive space isn't going to be accessible, period. That's going to be blocked off for this instance until it is removed. You can add extra virtual resources as you would like. You can allow it access to some of your USBs. You can allow it access to your printers, other settings, things like that to kind of make this system much more unique. All right. Once you've done all this, power it up. And you'll have to run a full, you'll actually have to go through the install process, uploading the new operating system, but you can start it up and then it will run you through the install and the setup and all that fun stuff. And once you've done that, your virtual machine is live. And then when you're done with it, power it down, you can leave. And then whenever you come back in, you power it back on. And it's like a virtual version of whatever you've created, be it Linux, be it Windows 7 or Mac or what have you. So pretty straightforward. Any other questions?
So using this virtual machine, I can run like a Linux, I guess, like base thing on my Windows like computer.
Yeah, absolutely. In fact, Windows actually has a Kali Linux app that you can download.
Oh.
So it actually runs on top of Windows. It's really cool. They just came up with that not too long ago. So unfortunately, not for Mac. We don't get to have any fun.
I don't know why people go to Mac. I'm joking.
Longevity, man. Longevity.
Like that's the only thing that Apple get going for them is like their product is just hardware is like just have longevity, but everything else, everybody just complain about them. They're like,
It depends on what you use it for, honestly. That's why you need to talk to people and understand what exactly are they going to be using the systems for the most part. And then that can kind of lead them into what systems would be best for them. There's not a one size fit all. Not every solution works for everybody. So it's just kind of is what it is. That's why I often say the Mac Windows argument's usually Chevy Ford argument. You know, when you talk to Chevy guys, classic car guys, they're like, Chevy's the best ever, you know, like Ford is terrible. And then you have the exact same argument on the other side. So say this because my stepfather is a Ford guy and my brother is a Chevy guy. So I get to listen to that all the time. All right. Any questions on this? Student pace, you can kind of walk through, use it as a kind of a step-by-step process for when you're installing it yourself. And you can give it a shot.
I also got another question.
Yes.
Let's say you were like in a job setting, and like you said, you had like, you know, those like hot seating and stuff. Like, is that some like, especially with the, I guess not especially this one, I guess more like for the virtual desktop interface, would you be, would you like, I guess, be allowed to like do something, set up something like that on your computer, or that'd be up to the like administrator of the job or stuff like that?
IT would be up to them whether or not they would allow you to do that. But
okay.
So what it is like, there's two different types of virtual environments. There may be one where this is real common in like call centers, where every time you log in, it's a fresh desktop. It's brand new, it's generic, it always looks the same. So every time you log in, it doesn't matter where you sit, doesn't matter what you do. Whenever you log in, they give you a fresh instance. So it can't be changed, can't be updated. And then there's the VDI, which is the virtual desktop interchange. And that allows you to personalize it. You could have different backgrounds, you know, you could have, you know, the applications that you use most on your desktop. You can have shortcuts, pinned applications down in your taskbar, all that stuff. And that would carry over every time you logged in. So a slight difference.
Oh, okay.
You can save files too. I used to do that on mine.
Yes, yes.
The
You would
notepad
save files and they
stuff.
would save on the server. So yes, perfect example. Thank you, Stephen.
Thank you.
So,
You can just kind of relate it exactly to your profiles on the machine. So if there are 5 people are in your house, you might have separate profiles on your computer for yourself and your child or wife or something. And you could click and change your user profile. It's the same thing on the server side. The server
Mhm.
keeps those the virtual desktop images as each individual one is your profile. It carries all of your app data and everything with it when you log in.
excellent. Yes, exactly. Thank you, Griff. All right, and always remember to power it off when you're done. Free up those resources. So some of the pitfalls. When you're setting it up, it's no different than doing a clean install on a regular computer. So it can have the same installation issues that you would normally see on a regular one. So you follow the directions, install it as you would on a normal machine. But if it goes bad, you can always delete it and then retry the install. So it's pretty easy to do. This can also help you in creating images. So you can test images you've created and see if they work out well. The other issue you might see using the virtual technology is using some of the same resources as the host. This is where you need to make sure you have enough RAM, enough CPU cores that can handle virtualizing as well as multiple VMs and still allow things to run kind of smoothly. Otherwise, it'll be a bit of a struggle. And then finally, the security concerns, which we talked about previously. They're just as susceptible to viruses and hacking that a normal machine would be. So you need to make sure your patches are up to date, your antivirus is up to date, all that kind of fun stuff in anti-malware, so that you can protect your virtual machines as well as your host. Questions so far? Yeah. Little quiz.
Mr. Kelly, can you please go back to the slide before now, real quick? Let me take a screenshot, please.
Oh, wait, all right. This right here?
Yes.
Yes.
Yes, thank you. Take a picture real quick. I got it. Thank you.
Beautiful.